Hello, we'll now discuss some selected questions from the third chapter in +1 physics, that is motion in a straight line. The first question says, the given graph shows the variation of velocity with displacement. Which one of the graphs given below correctly represents the variation of acceleration with displacement? So we have a Vx graph here with velocity on the y-axis and displacement on the x-axis. And we have a motion that is described with the help of that graph. And we should find the corresponding acceleration displacement graph, that is a graph with acceleration marked on the y-axis and displacement marked on the x-axis. So we'll start with the graph that is given to us. It is very clear here that along the y-axis we have velocity and along the x-axis we have displacement, x itself. Now, from the graph that you see here, it is very clear that the plot is a straight line and the straight line has a negative slope. So I can say that the slope m is negative because you can see the straight line leaning towards left. You can see that very clearly. And the value of the slope, the magnitude, will be tan theta if this angle marked here is theta, and that will be opposite side by adjacent side, that is v0 by x0. So minus v0 by x0 will be the slope of the straight line, and the y-intercept c for this straight line, that is the point where the straight line cuts the y-axis, will be plus v0. Now, with the help of all this information that we have gathered from the graph, we'll write down the equation that describes the motion which is represented in this graph. That will be y is equal to mx plus c, the standard equation for a straight line. In this case, we can write v instead of y, and minus v0 by x0 instead of m, which we have figured out already, and then we have x plus the y-intercept c is v0 plus v0. So this equation here gives us an expression for velocity in terms of displacement, which is exactly marked in the graph given. And we know that if I take the derivative of velocity, we get acceleration. So what I'll now do is to take the derivative on both the sides with respect to time. And please be very careful that we should take the derivative of velocity with respect to time to specifically get acceleration. So we'll do d by dt on both the sides. So we have dv by dt is equal to the constant minus v0 by x0 is taken out. Then we have dx by dt plus we have d by dt of v0. You know that dv by dt is acceleration and the constant stays intact, minus v0 by x0. Then you have dx by dt, that is time rate of change of displacement, and that is v or velocity. And then you have d by dt of a constant v0, and that will be 0, so that term disappears. And this v here is something that we've already figured out. So with the help of that, we can expand this equation here as a is equal to minus v0 by x0 multiplied with minus v0 by x0 x plus v0 in the place of v. Now, on expanding, we have a is equal to plus v0 square by x0 square x minus v0 square by x0, or I can even write it as plus minus v0 square by x0, and that is on expansion. Now, we have an expression here for acceleration in terms of displacement. That is exactly what we need, a in terms of x. With the help of that, we can plot an ax graph with acceleration on the y-axis and displacement on the x-axis. So now if I try and compare this equation here with respect to the standard equation for the straight line, that is y is equal to mx plus c. It's very clear that y corresponds with a, x corresponds with displacement x itself, m, the slope corresponds with v0 square by x0 square, c, the y-intercept corresponds with minus v0 square by x0. Now, be very careful here. It's very clear that the slope of this equation, when it's plotted on a graph, is a positive figure, and the y-intercept here is a negative figure. And definitely this equation here follows the pattern of a straight line. So my plot will be a straight line with a positive slope and a negative y-intercept. And that will be something like this here. You have a negative y-intercept and a positive slope. Now, if I look at the options and try and match it with our solution, it's very clear that the first graph here, option A, has a negative y-intercept and a positive slope. And that here is the correct answer. Option A is our correct answer.